And our last one was a yes. All right, now that we can decide whether something is a function or not by looking at the graph or looking at the equation, let's talk about after it is a function, they will ask you to find the domain and the range, and this will come up over and over again, and a lot of people get confused here. But let's talk about domain and range. Domain is the set of x values that are possible for a function. Okay, that's what x's can I plug into a function. And for that is we cannot have 0 in the denominator of a fraction. Can't have the denominator be 0, excuse me. So whatever number makes the denominator 0 is out of the domain. It cannot be used. Okay, so for this one, we could use any number except for 0. The other time you may have a problem with domain with your x's, not a problem, but it will exclude values, is if you have x under a radical. And the reason for that is we cannot find evaluate negative square roots. They're not real numbers. So whatever makes the inside of a radical negative is also out of our domain. So for this one, what you would do is you'd say, well, what would make that less than 0? And I would solve that. Anything less than negative 3 is out. So our domain would be anything greater than or equal to negative 3. The range, okay, many of our domains are all real numbers. Again, these are the only two things you would, well, not the only, but two of the things you would want to watch for. The range is the set of y values that are possible. And to determine the range, you have to know the domain first and see what the domain comes out as. Your range are your y values that come out of the function. So we're going to look at a few examples here. There's different ways that they can represent a function. For example, here we have 3, 4, negative 8, 2, 6, negative 1, and 5, 7. They've just listed the points that are in the function. So is it a function? Yes, it is, because we didn't have any of the x's repeated. What's our domain? I'm just going to use a D for domain. All you're going to do is list the x values. This was distinct points that they gave us, okay, and not like an interval. So we just list the points. The domain would be 3 and negative 8 and 6 and 5, because those were our x values for our points. Okay? Range is the y values. Yeah, these are the easiest range and domain to find is when they give you a set of points. So our range would be 4 and 2 and negative 1 and 7. Okay? We just listed the y. Okay? Domain is your x values. Range is your y values. Okay, if you need to take notes, pause for a second because I'm going to erase so that we have room for the next question. Here we go. Next. This is a description of our function. So this function is going to be x4, okay, and where x is an odd number. Okay. This is a function because our x will not be repeated, okay, right? We're going to have a different x every time. It just has to be an odd number. So it is a function. What is the domain? Well, it says the x has to be an odd number, okay? So our domain is all odd real numbers. Okay, that's our domain, straight up. Any odd number can be used as x. Even numbers can't because x has to be odd. What is our range? A range is our possible y values. Well, here they told us that y is 4, and it's going to be 4 every single time. So our range is just 4. The number 4 is our entire range for this problem because that's our only y value. We could try to write out some points. 0.14, the 0.34, and 94, okay? We couldn't write out all the values because there's an infinite number of odd numbers. But notice the domain, the x's, always an odd number. The range is just the number 4. Equations are tough. they're tough to determine range and domain. However, the little thing I told you up above, that the domain on an equation is probably going to be all real numbers unless, okay, they restrict it by putting a fraction with an x in the bottom. Okay, we can't have the bottom to be 0, or a radical, a square root. This does not have either. I could put any number, real number in for x and come up with an answer. Okay, nothing illegal would happen. So my range is all real domain is what I was working on there. The domain is all real numbers, which you can write out all real numbers. You can also use what we call interval notation, which kind of looks like a point, so it confuses us. But what you do for your intervals is you put where it starts. All real numbers starts at negative infinity and goes to infinity. This is another way to write all real numbers. Our range, well, we could also get any number out of that. So our range is also negative infinity to infinity, or, again, you can just write out all real numbers, but it's important to be familiar with this notation so that you know what it means. It means from negative infinity to infinity, anything in between. Okay, I'm going to erase again. Number 4 is an example of a function. They want us to give the range and domain, and since it's kind of hard to see where those points are, I'm just going to kind of have to guess. Okay, range and domain. The range is the x values, so we want to know what's our lowest x value on the graph and what's the highest x value. To determine that, we go, okay, how far does this graph go to the right? So I look at the farthest point to the right, and I look where that comes down on the x-axis. I'm going to have to erase to see that. Okay, so I just go straight down from here, and it looks like that's at -2. Again, it's a little blurry. Okay, so my x values go from -2 to, how far do I make it to the right? It looks like 1, 2, 3, 4. Okay, so my x values, there's no breaks in between. The graph is smooth. It doesn't stop anywhere. My x values range from -2 to 4. Now, we can't just write down individual points because it's a solid, smooth curve, not individual dots. So, again, we use that interval notation to write down our domain. Our domain starts at -2. Notice I used a square bracket this time. That means I'm including -2. And it keeps going until I get to 4, and then it stops. I'm including 4, so I put a square bracket. I know this notation is new, probably for most of you, so I'm just trying to ease you into it. This means it's not the point, -2, 4. It means all of the x values from -2 to 4. Everything in between. All right, let's check out the range. Okay, the range is our y values. So for y values, they're up and down, so we want to find the highest point on our graph and the lowest point on our graph. The lowest point, I'll do it in blue down here. So if I look at my graph, this looks like the lowest it gets to, and what y value is that? -1, -2. Looks like it's about -3. Let's look for the highest y value up here. How high is that point? Looks like it's about 8. So my y values range from -3 to 8. Notice there's no breaks in the middle. So my range starts at -3 and ends at 8. Okay? Notice I didn't just list the coordinates of the point at the beginning and the end. You want to look on the axis and see, where do I have points? Okay, where's my lowest point? Where is my highest point? It was everything between there. Again, this is interval notation. It means starting at -3, ending at 8. and including them. That's what the little squared brackets mean. If it's not included, you would use a parenthesis. And finally, here is one more example of a graph, the range and the domain. The domain is our x values, and for our that last graph, we said, okay, how far do I go to the left with my furthest point to the left? But notice on the left, I have an arrow, which means this goes forever in this direction, okay? So it's going to go to negative infinity to the left. Then I look over to the right to see if maybe it stops somewhere on the right. My furthest to the right is an arrow also. So that goes to infinity. So on the x, I go forever in both directions, okay? So my range is all real numbers, or excuse me, I keep saying range. My domain is all real numbers or negative infinity to infinity. I'm going to go ahead and erase so we can do our range. The range is the y values. So y values go up and down, so you're going to want to try to find your highest point and your lowest point. Well, the lowest point on the graph, I just missed, so I'll try again, is right there. Notice there's nothing below that blue line, which means we don't have any y values below that blue line, and so those numbers would not be part of our range. So anything this direction is not part of our range, only stuff above the blue line. Okay, where is that blue line? It's at 2. So our range is going to be from 2 and go up forever because of these arrows. Okay, so our range is starting at 2 and including it, and goes forever or to infinity. Okay, I know this is tough at first, but hopefully you'll get the hang of it. You're also welcome to ask questions. It's hard to ask questions when you're not right here, but send me an email or call me. Okay, so for this one, our domain was all real numbers or negative infinity to infinity. The range was from 2 to infinity. Okay, does this